Welcome back, folks. So, just got a order in from PCBWay, and I'm pretty sure it is the PCBs for our little 555 beginners project. Let's get this opened up and have a look at the boards inside. There we go. Get a knife here. There they are. Nicely done, just as we'd expected them. I always put this little flag on the back of my boards, especially the red boards. It makes it look like a Canadian flag. Well, it is a Canadian flag. It says engineered in Canada. First, just for fun. All right, so let's get all the parts required. Let's build one of these up and see how it works. Okay, so we've got all the parts assembled here and all the tools. It's always a good idea to have your solder sucker with you. You never know when you're going to need it. Everybody makes mistakes, and it's handy to have that right at your hand here to help out in those cases. And just waiting for the iron to warm up here. So as usual, we'll start off by putting in the lowest components first, and that's usually the resistors. So let's get started with them. Now, what you'll see a lot of more experienced builders do is put in all the resistors in one go and then go around with their iron and, get the tip in at the right position and solder them all up and then step off all the leads. I'd recommend that for an experienced builder, but for a beginner, it's always best to just do it one component at a time. Make sure the component is properly seated, and then trim off the leads, and then move on to the next component. The reason for that is it's too easy to make some mistakes and leave a lead unsoldered for the inexperienced. One component at a time is probably the best way to approach it. Take you through the process step by step. We're going to bend the leads down like that. Insert the component into the board. Push the component all the way up to the board as hard as you can, and then bend the leads over to hold it into that position. And solder it up. Make sure the tip of the iron presses up against both the land, and that's the little pad on the circuit board, and the wire of the component at the same time, and allow them to sit together about half a second or so, and then apply just a dab of solder. You don't want too much. Be careful not to put too much solder on. And then hold the iron there long enough to witness that the solder has spread down and into the hole, has wetted the lead properly. Now, we have our resistors put in, so the next components I'm going to put in are the little capacitors. We'll proceed with that. The same thing is true for them. Put the component in, hold it down, and spread the leads apart to hold it into place. Solder. Put the iron up against the pad and the component lead, and put a little dab of solder in. Hold it in there long enough to get to where it needs to go, and that's it. And trim the leads. Also, when you're trimming the leads, you don't want to cut right down at the surface of the board. What you want to do is cut the lead where it comes up out of the solder, right at that point there. So keep it as low as possible without getting right into it and cutting the solder off the board itself. And remember to clean your tip pretty well between each component as you put them in. keep your iron nice and clean. It works a heck of a lot better that way. Okay, here we are. This little jumper here just hooks up the LED. And I mean, you could remove that if you wanted to put something on that. They give you access to the output of the first 555 that you could run something off board with it. And you may not want the LED running, or you may want it running. It's up to you, but you can disable it by removing that jumper. And now let's hook up the speaker to here and the power to here and see if this thing works. Now before I connect up the power, I'm going to just check to make sure that positive goes to positive and negative goes to negative, and that we didn't make a mistake in our layout. So let me get the meter to do that. Okay, select continuity here. Okay, so plus should be coming up here. Negative should be coming up here. And the two should not be connected. Okay, good. Put power onto that. Negative on here, positive on here, and turn it on. There we go. Working as expected. That's great. Well, there we have it. Successful little project done with the help of the good folks at PCBWay. And I have to say that, you know, these boards are so nice to solder to. The HASL that they coat the board with, that silver coating, it's just perfect. It tins up beautifully. The solder flows on it very well, and it gets down through the plated holes and through the other side of the component. Because you can see here that we solder in this side, and the solder comes right through and comes up that side here. So it makes a wonderful connection. Really nice board. It's very well done. So let's look at a little bit of theory surrounding this. Okay, see how this works. So let's have a look at how the 555 works for us in astable mode. Astable meaning unstable or oscillating. So here's a block diagram of the 555 in this blue rectangle. From left to right, there are three main sections plus a discharge transistor. This first section here is a voltage divider network. This first node here is the trigger point below which the output is turned on. The second node up here is the threshold above which the output is turned on. And, you know, as we can see here, it's 5K, 5K, and 5K. So it's a three-way splitter. So with a VCC of 9 volts, we're going to have 6 volts for the threshold and 3 volts for the trigger point. Moving right, we have this comparator section here. These comparators detect when the voltage on pin 6 rises above the threshold, or the voltage on pin 2 falls below the trigger point. And they feed into this final section here, which is a simple set reset flip-flop that records the state of the device given what the information from the comparators tells it to do. So if we connect it up as shown, you know, with pin 6 and pin 2 connected at point N here,
And then the timing capacitor going from point N to ground. And then RB going from point N all the way up to the discharge point. And then RA going from the discharge point to over to VCC. This is the basic Astable circuit configuration. Now here we've also got reset connected to VCC. That's just to prevent any accidental reset of the circuit while it's doing what it's doing. When we first power up this circuit, this capacitor here, CT, will be completely discharged. Now since this voltage here at N going into the trigger is below the trigger voltage, this comparator here will set the flip-flop. So as soon as the power comes up, the device will be in the on state. Q will be turned on, the output will be turned on. Q0 will be low, and therefore this transistor will be turned off, so there'll be no current flowing down from the discharge pin. So what this means is that through RA and through RB, the timing capacitor is going to start charging up. And at that point, the voltage here at point N is going to start increasing. So both the voltage going into pin 2 and into pin 6 will start increasing. So once the voltage at N has exceeded the threshold voltage going into comparator 2, it resets the flip-flop to state 0 or off. This will turn off the output and turn on the discharge transistor, causing CT to begin to discharge down through RB. Once the voltage falls below the trigger voltage going into comparator 1, this sets the flip-flop and the cycle begins again. This just keeps repeating until the power is removed. Let's see how this works over here with the diagram. So once we turn on the device, the voltage on point N will begin to rise. It'll go through the 3-volt point, and then it'll reach the threshold. At that point in time, the flip-flop changes state, and the capacitor begins to discharge. And it'll come back down here until it reaches trigger point, and the flip-flop will be turned back on again, and it'll come back up to this point, and so on. It'll just keep going like this until the power is removed from the circuit. So what happens here is the output starts off high, goes low, stays low until the trigger is hit, goes high, stays high until the threshold is hit. Excuse my drawing skills, they're subpar. And it just keeps going like this ad infinitum. Now the nominal frequency of this operation here is given by this equation here. And you see RA is in there once plus 2 times RB times the size of the timing capacitor. And the reason RA is in there once and RB is in there twice is that it charges through both RA and B, but discharges through only RB. Ratio between RA and RB will set the pulse width. The closest you can get to a square wave is to have RA much smaller than RB. However, you can't go too small on RA because that will increase the current down through the transistor when the discharge cycle is occurring, and you can't exceed the maximum current. So there's a definite limit to how low you can go. And that's basically how it works. So here on pin 5, let's have a look at that now. This is exactly the same circuit that we used in our first oscillator, the one that blinks the LED. If we set the voltage here on pin 5, let's say to 8 volts, what that does is sets this point here, the threshold point, to 8 volts. And because we have a voltage divider going down to ground here, it sets the threshold to 4 volts. Now, instead of the difference here between these 2 points being 3 volts, it's now 4 volts. However, the time constant of the capacitor remains the same. Now it has to traverse a 4-volt change instead of a 3-volt change. So basically what's going to happen is, as you increase the voltage at this point through pin 5, the frequency of the oscillator is going to slow down. And by the same token, as you decrease the voltage going in here, the frequency of the oscillation is going to go up. So basically we have a voltage-controlled oscillator. So in our little project, we put a pot on pin 5 on the low-frequency stage, then attach the end point of the low-frequency stage to pin 5 of the audio frequency stage. And that gives us our adjustable warbling sound. Well, that's it, folks. I hope you enjoyed this little project, and I hope you'll join me for the next one. If you did enjoy it, consider leaving a like and subscribing to the channel. I'd also like to give a final thanks to our sponsor, PCBWay, for making this possible. So thanks for joining me, guys, and we'll see you in the next one.